What if humanity really made it to Mars? What would happen after that first step on Martian soil? Is living on Mars truly possible, or are we simply condemning ourselves to an inevitable fate? Today, we'll uncover what it actually means to survive on Mars. The conditions, the risks, the resources, and what science already knows about life beyond Earth. This isn't a story about science fiction. It's about the real boundary between survival and extinction. Since the beginning of space exploration, Mars has symbolized humanity's next great leap. The first flyby mission in 1965, conducted by NASA's Mariner 4, revealed a barren, rocky, and incredibly hostile world. Decades later, robots like Curiosity, Perseverance, and China's Zhurong have shown us that Mars is more than a desert. It's a planet that once had rivers, lakes, and possibly even oceans. But that doesn't mean it's habitable today. And that's where the real challenge of survival begins. The Martian atmosphere is composed of over 95% carbon dioxide, CO2. That means the air is completely unbreathable for humans. Atmospheric pressure is about 100 times lower than on Earth, equivalent to what a climber would experience 30 kilometers above sea level. The average temperature is minus 60 degrees Celsius, and it can drop below minus 120 degrees Celsius at night. Near the Martian equator, temperatures can briefly reach 20 degrees Celsius, but only for a few hours. These extreme variations make any complex form of life, and any attempt at colonization, an enormous technological challenge. Unlike Earth, Mars doesn't have a global magnetic field. Without it, the planet is exposed to cosmic and solar radiation. This radiation is lethal to living organisms, damages DNA, and even affects electronic systems. Background radiation on Mars is about 50 times higher than on Earth's surface. That means without proper shielding, a human on Mars could receive within months the radiation dose considered dangerous for an entire year on Earth. The only real protection would be to live underground or inside habitats covered by thick layers of Martian soil. Survival anywhere depends on one substance: water. And yes, there is water on Mars. But not in liquid form. Most of it is trapped as ice beneath the surface or at the polar caps. In 2018, the European Space Agency detected evidence of a possible underground lake of salty water. The problem is access. Extracting and purifying that water would require huge amounts of energy and specialized equipment. Another option is to produce water locally, by combining hydrogen from the Martian soil with oxygen extracted from the carbon dioxide in the atmosphere. Experiments like MOXIE, carried by the Perseverance rover, proved it's possible to produce oxygen on Mars, though only in small quantities for now.